Imagine floating in space, an astronaut looking out at Earth. Below, a breathtaking sight, our home. This is the overview effect, a feeling of awe and responsibility. Borders disappear, revealing a single, interconnected system. We share one tiny, precious world. Satellites now grant us this perspective, allowing us to see our planet in new ways. They help us witness global changes and comprehend our world. This understanding is crucial to protecting our home. Saving our planet starts with learning to see it. So what are these silent guardians? How do they help us safeguard Earth? Satellites are human-made objects in orbit. They come in all shapes and sizes, each designed for a specific mission. Some capture detailed images, others measure the planet's vital signs. Think of them as a global network, constantly reporting back what they see. They give us an unbiased, planet-wide view, revealing changes that would otherwise remain invisible. This information is for all of us. Data from these sentinels touches our lives daily. It empowers us to make better decisions for our planet's future. It's a story of technology, discovery, and hope for our shared future. So, what exactly is a satellite? At its core, a satellite is any object that orbits or circles around a larger object in space. The Moon is a natural satellite of the Earth. Earth, in turn, is a natural satellite of the Sun. But the satellites we are talking about are artificial. They are machines built by humans and launched into space for a purpose. Think of a satellite as a self-contained robot, a marvel of engineering designed to survive and operate in the harshest environment known to us, the vacuum of space. It must endure extreme temperatures, from scorching heat in direct sunlight to bone-chilling cold in Earth's shadow. It must also withstand a constant barrage of cosmic radiation. To accomplish its mission, every satellite has a few essential components. First, it needs a body or a frame, often called the bus. This is the structure that holds everything together, like the chassis of a car. Attached to this bus is a power source. Most satellites use large solar panels, like giant wings, to capture energy from the sun and convert it into electricity. This electricity is stored in rechargeable batteries, ensuring the satellite has power even when it passes through Earth's shadow. Without a constant supply of power, the satellite would just be a silent piece of space junk. Next, every satellite needs a brain. This is its command and data handling system, essentially an onboard computer. This computer processes instructions sent from control centers on the ground and manages the collection and storage of data from the satellite's instruments. To communicate with Earth, a satellite needs a radio transmitter and receiver, along with antennas. These are its mouth and ears, allowing it to receive commands from us and send its precious data back down to Earth. Finally, and perhaps most importantly, there is the payload. The payload is the whole reason the satellite is up there in the first place. For an Earth observation satellite, the payload might be high-resolution cameras, sophisticated radars, or sensors that can measure infrared and ultraviolet light. For a communication satellite, the payload would be transponders that relay signals. Each payload is a custom-built tool, turning a simple orbiting machine into a powerful instrument of discovery. Satellites are a diverse family, each designed for a specific task and placed in an orbit best suited for that job. The two most common orbits are geostationary and polar. Geostationary satellites hover above the equator at nearly 36,000 kilometers, matching Earth's rotation. Perfect for communication and weather monitoring, they provide real-time imagery. Polar orbit satellites travel from pole to pole at a lower altitude. This allows them to capture detailed images of Earth's surface. Essential for Earth observation, they monitor deforestation, track glaciers, and more. The magic happens when the information a satellite collects makes its way back to us on Earth. The satellite uses antennas to convert data into radio waves. These waves are beamed down to ground stations. The data is then sent to data centers where computers correct distortions and translate sensor readings into meaningful information. This data is archived and made available to scientists, agencies, farmers, and even navigation apps. This entire chain is a monumental feat of technology. It transforms satellites into active participants in the mission to understand and protect our world. Every satellite begins as an idea. How can we better track melting ice? The mission becomes a blueprint. Designing a satellite is complex. Satellites are born in clean rooms, pristine spaces. People wear special suits to prevent contamination. Inside, the satellite is assembled with surgical precision. Technicians install wiring, computers, power systems, and scientific instruments. It involves thousands of people working together. The machine begins to look like a true emissary to the stars. Before a satellite journeys to space, it must survive rigorous testing on Earth. engineers simulate the brutal conditions of launch and the extreme environment of orbit. The shake table mimics the intense forces of a rocket launch. Next, a thermal vacuum chamber simulates the vacuum of space. Inside, extreme temperature swings test the satellite's resilience. It's also bombarded with electromagnetic radiation. Engineers check the data, looking for any sign of weakness. A failure in space could mean the complete loss of the mission. Only after passing these tests is it declared flight ready. Then it's transported to the launch site. The satellite's journey culminates at the launch pad. Nestled in its container, the satellite is placed inside the rocket's payload fairing, a protective shield. Once secured, the fairing is sealed, protecting the satellite during its ascent. The final countdown begins, and with a thunderous roar, the rocket ignites. It lifts off, fighting gravity. As it climbs, the sky turns from blue to black. Above the atmosphere, the fairing splits, exposing the satellite to space. The rocket accelerates the satellite to orbital velocity. Finally, the satellite is released. It deploys its solar panels and sends a signal home. The satellite is alive and well, beginning its watch over our world. High above, satellites act as our planet's global weather watch, tracking clouds, winds, and storms. They are our frontline defense against the unpredictable nature of the weather. Today, we can see storms coming from days away. Satellites use imagers and sounders. Imagers capture pictures in visible and infrared light. Infrared sensors detect heat, allowing them to see clouds day and night. This monitoring is crucial for accurate forecasting. Sounders measure temperature, humidity, and pressure. This data is fed into supercomputers, which run weather prediction models. The constant stream of data makes forecasts accurate and reliable. It saves lives and property. Early warnings give communities time to evacuate and prepare. Beyond the daily weather forecast, satellites play an even more profound role. They are our primary tool for monitoring the long-term health of our planet's climate. Climate is not the same as weather. Weather is what happens today. Climate is the average pattern of weather over many years. To understand how the climate is changing, we need consistent, global, long-term measurements. Satellites are uniquely capable of providing this perspective, collecting data from the highest reaches of the atmosphere to the deepest parts of the ocean, year after year, decade after decade. They are the impartial, meticulous record keepers of our planet's vital signs. One of the most critical measurements satellites make is tracking the extent and thickness of Earth's ice. Using radar and laser altimeters, satellites can measure the precise height of the massive ice sheets covering Greenland and Antarctica. By comparing these measurements over time, scientists can calculate how much ice is melting and flowing into the ocean. Other satellites use microwave sensors to monitor the area covered by sea ice in the Arctic and Antarctic. This data has provided undeniable evidence of the rapid decline in Arctic sea ice, a clear and dramatic indicator of a warming world, with profound implications for global weather patterns and sea levels. Satellites also keep a close watch on our oceans, which absorb over 90% of the extra heat trapped by greenhouse gases. Highly accurate radar altimeters bounce signals off the sea surface to measure its height with millimeter precision. This data reveals two things. First, that global sea levels are rising as ice melts and as the ocean water itself expands as it warms. Second, by measuring the chemical composition of the atmosphere, satellites track the increasing concentration of greenhouse gases like carbon dioxide and methane. They are, in essence, taking our planet's temperature and diagnosing the cause of the fever, providing the hard data that forms the foundation of our understanding of climate change. This long-term global view is something we could never achieve from the ground. Before satellites, our understanding of the global climate was pieced together from weather stations, ships, and buoys, leaving vast areas of the planet unmonitored. Satellites have filled in these gaps, giving us a complete and coherent picture of our changing world. The data they provide is not based on theory or speculation. It is direct observation. This evidence is essential for international policy decisions, for developing strategies to mitigate the effects of climate change, and for holding us all accountable for the stewardship of our planetary home. When disaster strikes, chaos and confusion often reign. Satellites become our first responders, providing a clear view from above. High-resolution satellites deliver rapid images of affected areas, revealing collapsed bridges, blocked roads, and flooded neighborhoods. This information lets emergency teams target their efforts, saving time and lives. Radar satellites can see through clouds and smoke, working day and night, even during hurricanes or wildfires. GPS satellites guide rescue workers through damaged terrain, tracking teams and equipment with precision. International agreements ensure that any country can access vital satellite data during crises, regardless of their own resources. Satellites also monitor recovery, track displaced populations, and assess environmental impacts like oil spills. From immediate response to long-term rebuilding, satellites turn chaos into coordinated action. They are the backbone of modern disaster response, helping us save lives when every second counts. Earth's surface is always changing, shaped by forces both slow and sudden. Satellites use advanced radar to detect ground movement as small as a few millimeters, revealing swelling volcanoes, shifting fault lines, and sinking cities. This technology provides early warnings for eruptions and earthquakes, and helps manage risks in vulnerable areas. Satellites also map rivers, lakes, and wetlands, tracking floods and guiding emergency response. They monitor coastal erosion and the relentless advance of rising seas. This data is crucial for engineers, city planners, and disaster managers to build safer, more resilient communities. By watching the planet's surface shift, satellites help us understand and adapt to a constantly evolving world. They've transformed geology and geography, offering a global perspective that fieldwork alone could never achieve. With continuous planet-wide data, we can better manage resources and hazards. Satellites let us see the Earth breathe and help us plan for its future. Modern farming is powered by satellites, giving farmers superhuman insight into their fields. Specialized sensors detect crop health, revealing stressed or thriving plants invisible to the naked eye. Precision agriculture uses these maps to target water and fertilizer, boosting yields and reducing waste. GPS-guided tractors apply resources exactly where needed, saving money and protecting the environment. Satellites monitor soil moisture, helping farmers in drought-prone regions conserve water. This technology increases food production and sustainability as the global population grows. Satellite data helps ensure food security, making farming smarter and more efficient. It reduces pollution and supports sustainable practices. From orbit, satellites are transforming agriculture into a high-tech science. They help put food on our tables while caring for the planet. The view from space is feeding the world. Forests are Earth's lungs, absorbing carbon and supporting life, but they're under threat. Satellites act as tireless guardians, mapping forests and detecting deforestation in real time. By comparing images over time, they expose illegal logging and land clearing, holding offenders accountable. Satellites spot new roads and clearings, providing evidence for conservation efforts. They detect wildfires early, track their spread, and help coordinate firefighting and evacuations. After fires, satellites assess damage and monitor regrowth. They help protect habitats for endangered species and monitor the effectiveness of protected areas. This constant vigilance empowers conservationists to safeguard vital ecosystems. Satellites provide an unbiased global view, making us better caretakers of our forests. They are the silent watchmen, standing guard over the green heart of our world. The ocean covers most of our planet, and satellites are our eyes on this vast, mysterious world. By measuring ocean color, satellites track phytoplankton, the base of the marine food web, and identify productive fishing grounds. This data guides sustainable fisheries and helps prevent overfishing. Satellites monitor sea surface temperatures, giving early warnings of coral bleaching and other threats. Tagged marine animals transmit their locations to satellites, revealing migration routes and critical habitats. This information helps protect endangered species and manage marine protected areas. Satellites detect oil spills and illegal discharges, enabling rapid response and enforcement. They provide a global view of ocean health, supporting conservation and sustainable use. From space, we can protect the blue heart of our planet for future generations. Satellites are indispensable tools for understanding and safeguarding ocean life. Satellite technology isn't just for scientists, it's woven into your daily life. Every time you use GPS for directions or check the weather, you're tapping into data from space. Satellite insights shape the food you eat, the wood in your home, and even your vacation plans. Stunning images of Earth inspire us and connect us to the planet's story. You can explore satellite imagery online, seeing changes in your neighborhood or across the globe. Citizen science projects let you help researchers by analyzing satellite data. Satellites democratize information, empowering everyone to understand and protect our world. Next time you look up, remember satellites are working for you, keeping you safe, informed, and connected. They're an extension of our curiosity and our responsibility as stewards of Earth. The story of satellites is a story of connection between space, daily life, and the future of our planet. We began our journey with an astronaut, floating in the silent void, seeing our world for the first time not as a collection of countries, but as a single, fragile oasis of life. This perspective, the overview effect, changed them forever. It instilled a profound sense of connection and a deep feeling of responsibility. Throughout our exploration, we've seen how satellite technology gives all of humanity a version of that same transformative view. It's a new kind of seeing, one that transcends the limits of our own eyes and our place on the ground. This new vision, delivered by our robotic sentinels, is perhaps one of the most powerful tools we have for our planet's survival. This perspective is not just about pretty pictures. It's about understanding. It's the difference between knowing a forest is large and seeing its edges shrink year by year. It's the difference between hearing a storm is coming and watching its majestic, terrible spiral churn across the ocean, giving us time to prepare. Satellites translate the abstract concepts of climate change, deforestation, and resource management into concrete, measurable, and undeniable reality. They provide the global, continuous, and unbiased data that is the bedrock of scientific truth. This ability to see our world as one interconnected system is the first essential step toward healing it. From the clean rooms where they are born to their fiery ascent into orbit, these machines are a testament to human ingenuity and our unquenchable thirst for knowledge. They are the culmination of decades of scientific progress, the work of thousands of brilliant minds, all focused on a single goal: to look back at our home and understand it better. We built these eyes in the sky to see farther, and in doing so, we've learned to see deeper. We see the subtle breath of the seasons, the slow dance of the continents, and the unmistakable fingerprints of our own activity on the face of the planet. This new way of seeing comes with a profound responsibility. The knowledge our satellites give us is not passive. It demands action. It calls on us to be better stewards, wiser ancestors, and more compassionate inhabitants of this world. The view from space removes all our excuses. We can no longer claim ignorance of the consequences of our actions. The data is clear. The trends are visible, and the message from our silent guardians is unequivocal. We are all crew members on this beautiful spaceship Earth, and its future is in our hands. The question is no longer what is happening, but what we will do about it. The story of satellites is ultimately a story of hope. These machines empower us to take care of our world. They help us grow more food, protect endangered species, and respond to disasters. They reflect our drive to explore and work together for a common good. The mission to protect our planet is for everyone. Remember, you are connected to this grand cosmic perspective. It's the same technology that stands guard over our planet's health, a global utility built for the benefit of all humanity. It depends on you. When we reach for the stars, we often find a clearer view of home. We see ourselves and the planet we have the power to protect. With this perspective, we have a fighting chance. If you liked it, tap that like and hit subscribe so you don't miss what's next.